Everyone, welcome to Standard 7 Physics class, Chapter 5, which is about heat energy. In today's video lecture, we discuss about the mode of transfer of heat. You know that heat is a form of energy and that gets transferred from hotter object to the colder object. It means that a hot body loses its heat energy and a cold body gains the heat energy, and the transfer of heat continues until both the body attain the same temperature. There are three modes of transfer of heat. These are conduction, convection, and radiation. So first of all, we discuss about conduction. Conduction is a process of heat transfer from an object at higher temperature to an object at lower temperature. It means that the conduction is a process of heat transfer from a hotter body to a colder, from a hotter to a cooler end of a body, or between two bodies at different temperature which are in contact with each other. So you must have the experience that when a metal spoon is kept on a pan, boiling water also gets heated. This happens because heat from the hot liquid flows into the metal spoon by conduction. In this process of heat transfer, no movement of material takes place. There is no movement of material takes place in the heat transfer by the process of conduction. In solids, generally heat is transferred by the process of conduction. Some substances conduct more heat than the other. To demonstrate the transfer of heat through a solid by conduction, you take a metal strip, iron pin, a candle, and an iron stand to hold the metal strip. What you have to do? Stick the iron pins. Iron pins are stuck onto the metal strip using wax at equal distances. Fix this strap on a stand, and this strap is fixed on a stand. Now place a lighted candle below the free. This is the free end of the strip, and it is kept over the lighted candle. You will observe that nails closest to the heated end of the rod falls fast, and after that second nearest nails falls down, and so on. So we conclude that the heat is transferred from the hotter end. This is the hotter end, from the hotter end to the colder end of the metal strip, which caused the wax to melt and pins to fall down. Now, good and bad conductors of heat. The material which allow heat to pass through them easily are called conductors of heat. For example, good conductors of heat are all the metals are the good conductors of heat. Almost all the metals are the good conductors of heat, like silver, copper, aluminium, iron, mercury, graphite, etc. The material which do not allow heat to pass through them easily are called poor conductors of heat. For example, glass, asbestos, wood, water, air, plastic. The poor conductor of heat are also known as thermal insulators. Water is also a poor conductor of heat. That means water is also a thermal insulator. Uses of conductor and insulator in day-to-day life. Metal and alloys are good conductor of heat and are used for making cooking utensils. And the bad conductor of heat are used for making handles of cooking utensils. Bad conductor of heat such as bricks, asbestos, soot, etc. are used for building houses, as they don't allow the outside heat to enter the house during summer and don't allow the inside heat to move out during the winter. Glass, wool, foam, etc. are used in ice boxes, a refrigerator, to prevent entry of the heat from the outside. Now the second mode of transfer of heat is the convection. Now let us discuss about convection. The process of heat transfer in liquid and gases from hotter region to colder region accompanied by the movement of matter is called convection. While boiling water, the water near the bottom of the beaker gets heated and rises up. As the hot water rises up, the cold water from this side moves down towards the hot source. This water also gets heated and rises up. In this way, the whole water gets heated as the hot water keeps rising up and cooler water keeps taking its place. The continuous movement of water sets up convection current in water. The continuous movement of water you see here, when the water gets, in case of when this process of heat transfer is known as convection, it continues till the whole water attains uniform temperature. Okay. Land and sea breeze in coastal areas are common examples convection current. During the daytime, land warms up faster than the sea. This is the land and this is the sea. The land warmer than the water in the daytime, and the air above the land becomes warmer and rises upward. The cooler air from the sea rushes towards the land to complete the cycle. This air moving from the sea is called the air moving from the sea towards the land is called land breeze. Sea breeze. It is called sea breeze. And after sunset, when exactly it is exactly the reverse process occurs. Land loses heat faster than the water and the sea water. As a result, air above the sea becomes warmer. At night, the air above the sea being warmer rises up. The air above the sea being warmer rises up. Then the cooler air from the land rushes towards the sea. The air moving from the land towards the sea is called land breeze. The air moving from the land towards the sea is called land breeze, and the land breeze takes place at night and sea breeze takes place in daytime. Application of convection. Application of convection. Ventilation in rooms. Ventilators are provided near ceilings. The air we breathe out is warm and rises up. The warm air leaves the room through the ventilators. Cool, fresh air from outside enters the room through the doors and windows. Refrigeration. In refrigerator, the freezing chest of a refrigerator is always fitted at the top because it cools the refrigerator by convection. The air surrounding the chest cools and moves down while the warm air rises to the top. Now we discuss about the third mode of transfer of heat is radiation. We feel warm when we sit in front of a room heater or a bonfire. Just like light, heat from a room heater or a bonfire directly reaches us. Unlike conduction and convection, radiation does not require the bodies to be in contact or movement of particles. The transfer of heat by radiation does not require any medium. The transfer of heat by the mode of radiation takes place whether a medium is present or not. It means that transfer of heat by radiation does not require any material medium. When the sun rises and the sunlight reaches to us, the rays of sunlight does not require any medium. They passes through the space. There is no air between the sun and the earth atmosphere, but we receive the heat from the sun. So the heat energy from the sun reaches our atmosphere by radiation. When all hot bodies radiate heat energy, when the radiated heat falls on some object, a part of the heat is reflected, part is absorbed, and a part may get transmitted. The temperature of the object increases due to the absorbed part of the heat. Dark surfaces absorb more heat than the light surfaces. Due to this reason, we feel comfortable in the colored clothes in winter. Now we discuss about thermoflask, its structure and function. A thermoflask is used to keep cold and hot liquid hot for a long time. The thermoflask prevents the loss or gain of heat through the conduction, convection, radiation. So construction of thermoflask. The thermoflask consists of a double-walled glass vessel covered by an insulating plastic case. This is the double-walled glass cell, and this is the insulating case. The outer surface of the inner glass wall and the inner surface of the outer glass wall are silver. You see, the inner glass wall are silvered. Silver coating is given. The space between both the walls of the glass vessel does not have air inside it and are sealed from the bottom. The mouth of the glass vessel is narrow and covered by a plastic cap with thick insulation. How does the thermoflask work? Working of thermoflask. Due to the double wall, the content of the flask is not in direct contact with outside. This ensures there is no heat transfer by conduction. Absence of air between the walls of the glass. These are the two walls of the glass. Since there is absence of air between the walls of the glass vessel, ensure no heat is lost or gained by the process of convection. Silvered outer surface of the inner wall of the glass vessel act as a bad radiator and hence it does not radiate heat. The silvered inner surface of the outer wall of the glass vessel act as a good reflector of heat and hence it does not absorb any heat. The material that are used in the construction of thermoflask, glass and plastic, are all bad conductor of heat. This ensures that no heat is lost or gained through conduction. So there is in thermoflask there is no loss or gain of heat through conduction, convection, and radiation. So with this here chapter heat energy is completed, and the next video lecture we discuss about the next chapter. Thank you.